Good morning. Thanks very much, Lipin. Thanks very much to the organization for bringing me the opportunity to be here today and present the results of a project. This has been a project going on for the last few years, and I'm very, very honored to be the person, the messenger of this effort. This is a team effort. Has been a great team working very much, and they have done enormous work collecting many different data. And today I'm going to try to summarize the main results of this work. As you can see, it's different institutions from Spain because it was a Spanish-funded project, but also we have many collaborators abroad that have contributed to this project. The name of this project was Opera. This project was set to understand to use different archives, climatic archives, to reconstruct climatic changes around the Iberian Peninsula. We are combining espeleothem, ice caves records, and also marine sequences. We wanted to understand complete changes within the ocean and the atmosphere, and we also wanted to understand changes in the ocean chemistry. So it was a very ambitious project. It was a really challenging project. And I think that we can be very proud of the results. I would like to start just highlighting that one of the big outcomes of this project has been the successful results coming from the ice caves. Carlos, Miguel, and also Maria, who had yesterday a poster, they have been very brave, really brave, to do the sampling of these caves, of these very fragile archives that we have now. And they are demonstrating that these ice cave sequences can be well dated, and I'm sure that in the near future they are going to provide very good paleoclimatic records. But today I'm going to focus in the results coming more from espeleothem records and marine records. The espeleothem records have been combined with a tremendous effort of cave monitoring. We have been monitoring different caves in different sectors from the Iberian Peninsula, and we are combining these records with marine sequences. This was our main goal. The main goal of this exercise was trying to understand how changes in the ocean circulation could affect hydrology over Iberia. And also, the fact that we are combining 3 different regions over Iberia allow us to see how this signal changes from the more Atlantic sector towards a more Mediterranean sector. So how we have achieved these objectives? We have been working, as I say, with 3 different sectors. And coming myself from the marine world, I'm a marine original person, when we go to the espeleothems, I have to confess that one of the very frustrating things is to get continuous stratigraphy. It's really challenging to get a continuous stratigraphy. But I think we are doing pretty well in trying to complete a record of the last 500,000 years. But today, what I'm going to do is focusing in those results where they are more advanced. Those results, some of them, they are almost already published, and others are in the progress. I'm going to talk about stage 7, termination 3. I'm going to talk about stage 5, termination 2, and then I will go to the Holocene, looking to different time scales, even the instrumental part. The through line of my talk is going to be I'm going to organize all this data through the role of changes in the Atlantic circulation on these patterns. So I'm going to show you a lot of data. I'm going to try, I have done an effort trying to put an order on this data, because really, a lot of data here. I'm going to start with termination 3. This is part of the PhD from Carlos Perez. He is actually working now in the revision of this manuscript. We have a espeleothem, very well dated. It's coming from the central sector. I didn't say that. It's coming from the Iberian range, this record. And we have a very good chronology with uranium, thorium data. And also, we have completed this work with a monitoring, 3 years monitoring of the K, which allow us to interpret the carbon-13 data as a proxy of hydrological changes in the region. Here we have the record. It's the green line, which I can know. It's the green line where they say a Hulbeck cave. These are the results. And what you can see really is the termination 3, with a change in humidity getting to wetter conditions, and then acidification towards the -7. I want to focus in the two events previous to the termination 3, where we can see a very arid conditions, relatively arid conditions, which are the higher isotopic values. And this condition seems to be related to IRD in the Atlantic Ocean. So that is in some way confirming a pattern that we already know, that changes in the AMOC really have a strong impact in the humidity over Iberia. But this record is providing us accurate chronology for this time interval, for this termination, independent absolute chronology, which was not available. Now we are moving to MIS5. This is part of the PhD from Judith Tournay. And here she is showing results from two espeleothems, one coming from the Balearic region, another from the Pyrenees. And she has more espeleothems from that period, but this is the most advanced. And what I'm showing here in green is the carbon isotopes, in blue the oxygen isotopes from the espeleothems, and in the lower panel in red are the sea surface temperatures from marine records also produced by Judith. And you can see that the two isotopic curves, there are some shared features, but they look different. If you focus to the green one, to the carbon isotopes, you can see that each single stadial in the Greenland record can be observed with dry conditions in Iberia and the Balearic range. Can be these very dry conditions, and also we can see in the marine record this calling. As I mentioned, the oxygen carbon, it looks different. And now in the next slide, I'm going to focus in this oxygen record, the blue curve, that I'm showing in the other one, comparing with other records from other regions. Now, I have to say sorry, but the previous blue line now is in green. The green line is the oxygen isotopes from the region, and when I want to compare the two green lines are two different espeleothems, one from the Pyrenees, another from the Iberian ranges. The oxygen isotopes, they share the same patterns. I want to compare these two curves. They share patterns, and when we compare with the oxygen, marine oxygen reconstruction, seawater, we have removed the temperature component. We can see that they share this pattern with the Mediterranean waters. So we argue that this is a signal coming from the water source of the rain. It's Mediterranean rain, and this has this typical precession pattern as observed in Israel espeleothems. But if we look to a stack coming from the Cantabrian region, from the north, we see that this pattern is not shared. It's a different one. And we believe that this is true, is really because the rain is coming from different sectors. They have a different patterns. And probably some of you have already noticed a structure here. It seems related with termination 2. To get termination 2 is really difficult. It's difficult to find in Iberia espeleothems with termination 2. And if we look to this structure again, we see that it precedes termination 2. We have a lighter anomaly, and now Heather-Stoll has increased the resolution of these records. It has two very well-dated records, and she's confirming this structure. It happens, it occurs. We have a fresher structure in the Atlantic, which is not happening in the Mediterranean espeleothems, although we have it in the marine record, and we are associating this anomaly to changes in the Atlantic circulation. Now, I'm moving to the Younger Dryas period, and here we have a espeleothem which was growing very, very fast during the Younger Dryas. So that's allowing to get a very precise chronology and very detailed paleoclimatic record of the Younger Dryas. This was part of the PhD from Dr. Bartolomé, who has already completed his PhD, and he was able to produce two very extraordinary records, one of oxygen isotopes, which we are interpreting in terms of temperature, and another one of carbon isotopes and also magnesium records. But I will argue now that is mostly changes in precipitation. These records show that during the Younger Dryas, here we have the Holocene, here we have the glacial period. So during the Younger Dryas, we have a change in the precipitations toward more humid conditions, coming from drier to wetter conditions. And this is a pattern that was already observed in some sequences, in some records from Europe. It was not new in some way, it was new for the Iberian Peninsula, but these changes in humidity were already described. So I'm going to compare now this record with these sequences and some marine sequences with similar resolution, comparable resolution to this record. And I have to apologize because I'm going to change the direction of the record now. Yes, Holocene is here. Here we have the glacial. This is the Younger Dryas. Here we have Greenland and the temperature record from the Pyrenees. And here we have these other records from Europe, located here in this map, where we have seen, it has been observed changes in precipitation. These are the records from Miguel, and this is marine records, which in some way are sensitive to changes in the AMOC, dynamics. And what they show these marine records is that there's a change across the Younger Dryas with a strengthening and increase in the strength of the AMOC along the Younger Dryas. So what we are claiming at this change, what produced are changes in the polar front position and the position of the westerlies that led the westerlies to bring humidity towards Europe. And that migration was progressive, and that's what produced a signal, a different signal across different latitudes, and a different response according with the archives of the lakes or the system. Up to now, I've been talking about changes mostly during glacial periods of terminations. And these are periods where the system, they have a very strong response. We are talking about really major climate changes with a very strong, and in some way, as a very clear and strong signal in our proxies. So probably it's a bit easier to interpret. Now, I want to move to the Holocene period. As you know very well, the Holocene is the most studied period, but at the same time is where we have really difficulties interpreting our proxies, because often the signals are not so clear and it's very ambiguous in some way. So I'm going to try to do an exercise to show some new data comparing with previous one. I'm going to start with the whole Holocene period. And this is our new marine records coming from southern Spain, from the Alboran Sea. This is part of the PhD from Albert Català. And here I'm showing in the lower panel, this is a sea surface temperature record, a new magnesium calcium sea surface temperature record from the region, where we can observe very nice centennial, millennial variability and also some trends. Above, in orange, you have a record. This is an XRF zirconium potassium record that we are interpreting it in terms of changes in humidity, in radiant dynamics in the south of Spain. We have, this is Argo, and based to some information, background information we have the region, but I think that we are monitoring changes in humidity patterns in Iberia. We have validated this hypothesis comparing with Pelion sequences. You have one above coming from the marine record, from William Fleischer, who was here yesterday, and we can see there is a good agreement showing that there was starting the Holocene with getting wetter conditions, from dry to wetter. We have maximum humidity conditions in the middle around 8, between 7 and 9,000 years, and then we have acidification and really a strong change in patterns around 4,000 or 5,000 years. This is a pattern which has been well described. Actually, yesterday here in this room, there were several of you speakers that they were showing similar records. It's quite well established, even though regionally it might be small changes in the absolute timing and structures. But it fits very well with what we understand from the system. But since our life is complex, sometimes when we produce more data, stories become more complicated. And now I'm going to show these three records, the two marine records, the zirconium and the temperature, and I'm going to compare with other data we have from the Molinos, from the central sector, and also from the Atlantic sector. And as you can see, the light green curve, which is the Molinos stack, is a stack of several espeleothems. It's a relatively good chronology. And as you can observe, the story is telling seems to be opposite to the pattern I have described. We have fresher, wetter conditions in the very early stage of the Holocene, a sharp change toward drier conditions, toward drier conditions, and then it seems to be a slightly wetter trends toward the Holocene. So a completely different story. This is not the very first time that happens. There are sequences in Italy where they are showing this pattern. And I have to say that Ana Moreno, who is working with the sequence, has supported where she really argue that these differences can be reconciled when we think about the changes in sensonality and the different response and sensitivity of proxies and archives. So there's a good reason probably for these differences. And now I want to focus in the upper panel, the one which is coming from the Cantabric. This is growth rates from the espeleothems, from several espeleothems from the Holocene, and what we can see that fresher, wetter conditions agree to be almost within 8,000 years. Very coherent. And then currently they have this acidification phase in the middle of the Holocene. So what I want now to claim, to argue, that these changes in humidity, these changes that we can observe, I mean, these records, we can see that there's like a strong change in the patterns through around 9,000 years, 4,000 years, and I want to argue that they correspond to changes in the dynamics of the Atlantic circulation. And it is changes in the Atlantic that they are changing patterns, the behavior of the climatic system of Iberia. So for that reason, what I'm going to do now is to compare these records with some records of ocean records from the Atlantic. This record is coming from the Cantabrian Shelf. It's a really well-dated core. Actually, this is a composite of two different cores from the Cantabric. And these are isotopes, oxygen isotopes from a benthic foraminifera. It's very shallow core. We are within 150 to 100 meters. And what we are looking is changes in temperature of the subsurface water masses, which are water masses formed in the subtropical gyre in the Atlantic Ocean, and probably in the subpolar gyre. This is an hypothesis we don't know. We actually are working now with neodymium data to try to understand better what is happening, what these changes are. But I want to stress that when we are starting to get a cold water mass, this indicates a cooling in the subsurface waters, is one we started to get drier conditions over the Cantabric. I mean, it's a closed region. We think that these two dynamics are really very much related. And also would like to draw the attention to this record here, which is a published record, a site further north. These are data coming from deep corals, deep sea corals. They are neodymium data. And the information you see here is a change in the source of the intermediate water masses in the Atlantic. And it's argued in this paper that we are moving from waters coming mostly from the subpolar front to waters that are more from the subtropical gyre. So that could be consistent with our change here that this cold water mass is removing and is coming a warmer water mass. So we believe that these changes in our ocean circulation really have a strong impact, changing the climate dynamics over Iberia. Now I'm going to focus in the last 4,000 years, which are the moment where we have a stronger variability, centennial, millennial scale. For some reason, this change in the system allowed the system to be more unstable, and we will have stronger changes in that period. So I'm going to do a zoom to that period. And I would like to start comparing with this record that is a record of runoff events in Mediterranean rivers. And when we see that we have stronger river events happen when we have more humid conditions, also in the Alboran Sea, colder conditions, but this is a very interesting comparison with a espeleothem from the Cantabric, also more humid conditions in the Atlantic. We have the same rapid variability. So it's current to think that we have the arrival, this event corresponds to the arrival of colder waters that bring humidity in the ranges of the Cantabric ranges, but also let colder water to come into the Mediterranean, changing also humidity patterns. Now we are focusing the last 2,000 years, and we are going to the Balearic sector. These are espeleothems This is part of the PhD from Merced Cisneros. And we have been very lucky to collect a family of espeleothems, a family that they have a reasonable overlap within them to be able to produce an almost continuous record of the last 2,000 years in the Balearic region. And this is oxygen isotopes. We are doing monitoring in 3 caves in this area. So we are starting to be very confident that oxygen, carbon, and magnesium calcium can be interpreted together. It's PCP and is related to changes in the humidity in the region. And what comes out from this record is that drier conditions dominated in the later part of the Roman period, also during the medieval climatic anomaly, and also happens to be in the last century. Merced is doing a big effort to try to understand the connection of these changes with marine conditions. It has produced a marine record stack, which is already published. And what we can observe that the story is really complex, but it comes out really that when we have warm conditions in the sea, it seems that we have dominant dry conditions on land. I want to look into the last centuries in the instrumental record, so I'm going to focus in the last part of this record, and I'm going to compare it with the other 2 sectors we have been working with. These are the Pyrenees, where we have a stack coming from several 4 stalagmites. This is the same Balearic record I was showing before. It's a single espeleothem for this part, and here I'm showing 2, but soon we are going to have 3 more records for this part. And this is a stack coming from 3 espeleothems from the Cantabric. They look different, at least in part, because I think we think that they are telling different stories. Oxygen isotopes in the Pyrenees, we believe that is temperature signal, carbon, oxygen, but also carbon, is telling us about humidity changes in the sector. So to validate this hypothesis, whether it's temperature or it's rain, we can compare with other records. I have chosen now the Pyrenees record in the upper layer, and the lower is the Balearic one. Since we believe that the upper is temperature, I have chosen a record coming from the Gulf of Lions. This is Alkenon record from Alexandrine Secret. And you can see that even though that we have different resolution in the marine record, but the patterns really agree, supporting this hypothesis of temperatures. In the lower panel, what I did is compare with the now reconstructions. And it seems that for the last centuries, there's a good agreement with high now values, more drier conditions, which is coherent about how we understand the system works in the region. Also, for the last century, this relation is not so clear. But another way to test this hypothesis about the interpretation of the proxies is to compare with the actual instrumental record, which is going to be my last data slide. We have been able to compare in the Pyrenees the records from few espeleothems with the temperature records, and we are very confident that it's not the only signal, but it's the dominant signal temperature in this espeleothem, oxygen espeleothem records. And also in the Balears, here I'm showing very high resolution laser ablation record. Thanks to Miguel Iglesias, we have been able to reconstruct magnesium calcium with a very high resolution. And I'm comparing this magnesium calcium record here with the instrumental record of precipitation in Mallorca. And still, we are working on that. I mean, still working with the age chronologies, but it seems really promising that we are capturing the multidecadal climate variability of the region, and we really have a precipitation record from the area. I would like just to finish highlighting probably the main points I've been talking about. I think that we have a strong basis to say that during the interglacial 7 and 5, there's a strong connection during termination 3 and 2. We have a strong connection within AMOC dynamics and changes in precipitation in the Iberian Peninsula. When we go to very detailed into the younger dryas, you can see that even during minor changes inside a single event like the younger dryas can be detected in the humidity changes, at least in the Pyrenean region, with a change in the rain patterns related to the changes in the Atlantic Ocean. And also looking to the Holocene, I think that we can see that there is changes in the main patterns, in the main dynamics of the rain patterns, but also temperature in the peninsula, with a strong change, two strong changes, like two thresholds, around 9,000 years and around 4,000 years, but we believe that are related to changes in the dynamic of the Atlantic Ocean. We have shown some evidences, and we believe that this change in the Atlantic changed the system and the response of the very climatic systems to precipitation and relation between precipitation and temperature. And we have shown that during the last 4,000 years, we have very strong variability, and we see there is a good coupling changes in the southern Iberian and also in the Cantabric, with also things related to different ocean dynamics. We have records for the last centuries and the instrumental record that can validate our espeleothem records, and we really are very secure that we can capture climatic signals to reconstruct past changes in Iberia. So I just want to thank you for your attention. I want to thank this very great team that has done a tremendous effort during the last few years, and the funding agencies, which has been mostly the Spanish agency. Myself has to thank ICREA from the Generalitat of Catalunya, and also this project has been the inspiration from an ERC project that is just starting now. Thanks very much.